Thank you. Hello and good afternoon. So I'm Tom Vogels. I work at Harry's, lead the data engineering team. And what I want to talk about is a project we ran that ended up in a data platform that's supposed to support a large range of applications, most prominent among that certainly a BI tool, a business intelligence tool like Looker. And we wanted to embrace Redshift as one AWS service, and then the other AWS service is to actually get data into Redshift. So EMR, data pipeline, all the EC2s. That's one side, data, getting it into Redshift. The other question is, how do we support our teams to actually make that an efficient workflow? And so that is actually also a very important aspect and sort of the second part of this presentation. If you haven't heard of Aries before, we provide grooming supplies. We aim to make your morning routine better. So if you haven't heard of it before, you can go online, check up on us, and sign up for a free trial. If you do that, and that's the point of this, is you will create a row in the users table. You're a new user, you will create an order. So there's a row in the orders table, a payment, a shipping tracking information. Once you received your package, we'll check up on you whether you like our product, so that creates email information. This is what I want to look at, e-commerce data. E-commerce data has a bunch of applications upstream, and is sort of, because of that, a little complex, always a little dirty, and you have to clean it up to get it into the warehouse. What I don't want to talk about is sort of on the other side is event streams. So normally when you think about Redshift, millions, billions of events, that's great, usually much more straightforward. E-commerce is where it gets complex and you have to run transformations. On the one side, on the other side, if you really want to embrace Redshift, that means you have to start thinking about the architecture. So the purple node in the middle is the leader node that will receive your query and then has to think about how to distribute it to the compute nodes. That means you have to think about your data. How can your data reside in the compute nodes such that I can execute in parallel? So these are our two questions. Embrace Redshift, by the way. If you go for it, don't treat it as a baked Postgres, copy things in there and hope things will be okay. You have to think about how to structure your data, how to distribute your data, how to encode it to really make the best of Redshift. So that's one set of questions, and the other set of questions is, all right, I want to run these transformations, I want to play with different encodings, I want to play with different distributions. How do I get to an efficient workflow? I don't mean to coin a new term here, so I'm thinking of this as a percolator. It helps me think about it. So at the top you start in databases, and then your data percolates through that. And when I say at the top, they're databases, these are your other applications. It doesn't have to be a database. It could be just S3 bucket with a bunch of CSV files that another application has written. From there, it enters into Redshift. So the dashed lines are sort of the border of your data warehouse. And the first thing we do is we dump everything into, you have no color, I just noticed. So there's a bunch of schemas at the top of tables that receive pretty much one-to-one your application data. And then you start cleaning it up, because that's your application data, but that's not how your analysts think about it. They are from a finance team, they are from operations team, they are from marketing team. So now you start transforming that or reorganizing your data. And when you think about a warehouse, you probably also think about a star schema, because they just lend themselves nicely to run in parallel. You have a fact distributed over your nodes, you have your dimensions copied onto the nodes, you can let it go. So you will run all these transformations so that finally your BI tool or other applications can leverage this data. So things to point out here is we've set a hard boundary at the top. So as I said, we copy everything first into data tables for the sources, but analysts don't have access to that. That gives me, from data engineering and analysts, the opportunity to change our implementations. We can change the top and then transformations to make sure that the view for analysts remains the same. The other thing is, if you do data modeling every day, if you do star schemas for a living, it's natural for you to select from fact, join on the other dimension, non-dimension keys, and one more dimension, another dimension key. That's great for you. If you're an analyst, this may not come natural to you. So we have actually an analytics schema that provides a bunch of views that has some of these joins already done. And my pleasant surprise is really that Redshift does really well figuring out what it does and doesn't need. It really doesn't seem to slow it down, although you have just pushed out this complexity. All right, so how do we organize all this? Strictly speaking, we are running an ELT, not an ETL. So we extract first, either you already have S3 with CSV files, or you have a database, and we picked Scoop as the software to actually go to databases and then create CSV files for us. Then you load, so that's the first layer in Redshift where we just bunch everything in from upstream data, and then we start transforming that. Now, if you think about it, as you start transforming that, there are probably other transformations you rely on, so there has to be a certain sequence that you have to obey to go from your sources down your transformations down to your star schema. So, let's go through a couple of questions you should have at this point from easy to hard. The easy answer was, let's use data pipeline to orchestrate everything, run everything on a schedule. We'll use S3 really as our data hub where code lives, configuration lives, and the data lands that is extracted. We'll create files of meta information because you have to drive that ELT. So I'll talk about what is in those meta information files. And finally, how do we get to a point where we can really efficiently iterate over workflow? Because you will find new ways to transform your data, you will find missing data, you'll find new data, so how do you update your warehouse? As I said, data pipeline was the easy choice. The only surprise here was a little bit for me is that resources and activities are in the same dependency graph. Once you get past that, it's actually easy. So you start with a schedule at the top because it doesn't depend on anything. In our case, this just kicks off every 24 hours of pipeline. It brings up a resource, which is the EMR cluster, that then can kick off an activity, which is Scoop to actually extract from upstream databases. In parallel, you can start warming up your EC2 cluster or EC2 instance, start bootstrapping it, and when the extract is done, you start kicking off the load and the transformations. At the end, you can do more. You can do publishing of S3 state so that you can revert to it the next day or inspect it. Another nice thing about data pipeline is that SMS alarms already built in. So when the ELT is successful, we get an email, success. When it fails, we also get an email, but we can also get paged. So that all of that is very easy to set up. That brings me to the daily rhythm of ELT. There's not just one, there's a one at midnight that rebuilds the warehouse, and then actually 3 more sort of at 6 hours intervals throughout the day that load straggling data, summaries throughout the day, and 1 more ETL. So there is a 5 o'clock validation pipeline. That job of that pipeline is actually not to load anything. It is to make sure that I can talk to upstream databases, is my configuration correct, did my passwords change, did I deploy any code where the SQL potentially doesn't run. So that runs at 5 o'clock. We'll get before end of business day information, confirmation, so that we don't get woken up at 1 o'clock because of an error. So then let's go to the next step up. How do we coordinate this within S3? And so this should be no surprise, and I'm assuming, hoping everybody does that. What you do in your warehouse is code. So that should be under version control. You should have a repo for that, out of which you load it, push it. That's where you derive the state from your warehouse from. That can be your upstream configuration, which other databases do I talk to, what is up there, what are the users that I log in with, as well as your tables, your schemas, and so on for the warehouse itself. That all gets deployed to a bucket, and then the ELT commands pretty much take that as truth and run off of it. There's another bucket on the right where the actual data lands. So if you run Scoop, you go create CSV files, they need to be left somewhere so that I can then copy them into Redshift. The other thing that ELT will drive through is SQLs is CTAs and views. CTAs are create table and select statements. Think of them as tables that are derived from data from other tables that are now materialized, or you just have a view that you instantiate and now use your data. That brings us to more information that is in these buckets. So how do we actually know which tables to create, in which order do we create them, what do they look like? So this is meta information. It says here YAML files, which is just generic markup language. And so these files really contain for us, what is this table? What is its name? What is its description? What are the columns inside of it? What are constraints? One interesting thing to point out here is constraints are not naturally checked by Redshift, other than they're not a constraint of a column. So we just have it in code. It's a really nice thing to sort of have guarantees as constraints. So if you want to say this is a primary key for this dimension, then we're actually checking this is true. And the other thing is you will find and play with attributes. So these are your sorts. How do I sort my data, or how do I distribute my fact across various nodes? So all of this lands in this meta information file where I can derive now the actual create table statement for Redshift, where I can derive from how to load it. If you have transformations as a set, they will depend on something else. So you have a list of things that it depends on. That sounds a little scary by itself. Where does this information come from? And so this is now where we get into the realm of make sure you have an efficient workflow. So in the case of an upstream database, you start with a database, right? So you have a bootstrap command that creates that meta information for you, makes it really easy to then push a create table statement into Redshift, load the data, copy it in there. If you run a transformation, then what comes natural to you is to actually create the transformation. You sit in your favorite editor or in your command line and you write SQL until you're happy with your new, let's say a new dimension. You write a dimension for discount codes. This is where you naturally start from. And this is actually where we also start from. So the tool is smart enough to just pick up your SQL, figure out what the meta information is, figure out what tables it relies on, slots it into the right sequence. The other thing to point out is you're free to welcome these bootstrap things. Example is if an upstream database might contain a parameter hash, has no business in the data warehouse, you can mark it as skipped. Just make sure you run validate after it so that it's semantically correct. Same thing if you run SQL, you might choose that it's not the perfect meta information file, you can change it, just make sure you validate it, and then it goes out to S3. Dependency graph, really easy. As a tool, it's straightforward to make sure when you load and transform segments, it's done in the right order. And for users, you don't have to worry about it. You write your SQL, you let the tool take care of it to figure out what a dependency is. And I have to put in a shaving reference here somewhere. So allow the rinse repeat. Chances are you won't get this right the first time. Chances are you have to change your transformation or you find a bug. So that's fine. The tooling is there. Go back to Bootstrap the meta information, validate it, make sure syntax and semantic is correct. Deploy it with a sync to S3. You can run the extracts and the loads individually. Loads you can even do outside of a pipeline. And I have one more command here is upgrade, which is sort of a surgical way. If you have a new transformation, you want to push that into your warehouse and then update everything that depends on it, right? But not touch the other transformations that are not touched by the data path. Why did we do this to ourselves? There are certainly alternatives out there for ELTs, and that sort of is what I'm seeing is a lot of EL focus. Database migration service from AWS certainly falls into this category. I'm watching very carefully AWS Glue. They're a little bit more on the Python side, but I'm sort of wondering what will happen on the SQL side that we'd like to have first and foremost. And certainly there are third-party tools out there, but they always seem to be focused more on the E and the L. Cool Cuts these days orchestrate with Luigi or Airflow. We don't even orchestrate, we have pipeline. Because if you think about it, you really have one task that opens up one transaction to your warehouse. I don't need a lot of orchestration to have a single task running. So the questions that I want you to ask yourself as you go through this, don't treat Redshift as a supersized Postgres. Think about what does it mean to have a column store distributed over your compute nodes, how do I encode it, how do I make sure I can run parallel execution, how do I run the transformations to really clean up my sort of messy e-commerce data, and how do I do this efficiently? And this is where the tooling really comes in, to bootstrap the meta information to make sure you can run the individual steps of the ELT. And then finally, the tool itself is the orchestration of the L and the T stacks. Status is so that we've started this a little bit more than a year ago. We have been in production a little bit less than a year ago, so split the difference. We are about in production for a year. Really happy with how data pipeline has worked out. The other services, EMR has worked out to get data into Redshift. 5 o'clock pipeline. If you haven't thought about it yet, run something before the end of business day to make sure everything's cool because you don't want to be woken up in the middle of the night. And when you have bugs as they creep in or you have new ideas, just make sure you have an efficient workflow to then update your system. Make sure you can make shared progress. So we can run validation pipelines anytime, doesn't have to wait till 5 o'clock. If you think you have something ready to go to production, you can just run that. And we arrived at a platform that we're happy with, and that sort of is where we jump off from for feeding other systems. Think of customer management, think of ticket targeting as it comes in. We aren't done yet. We'll keep pushing this tool. We need to think more about the columns, how they're encoded. What I said initially is we have from the top the databases extracted, loaded, and the rest of first pretty much one-to-one. I'm starting to wonder why, because there's Redshift Spectrum that actually could do this very well for us. So we'll look at this, but we'll always keep an eye on making sure that we have an efficient workflow for analytics teams. That's the end of the prepared portion of this presentation. As it says at the bottom of it, this tool is actually, since a few hours ago, open source. I hope I didn't screw up too much as I copied it over and flipped the switch. Yeah, and of that, I'm happy to entertain any questions.